In this problem, we are asked to find the delta H of this reaction here when we are given the equations and delta H's for three known reactions. And so we're going to use Hess's law with this. So the first thing I want to do is just kind of look to see what do I have that's already the way that it needs to be. And the first one I see is the CO2 in the very first. It's on the product side, and there's a 1 by it. So I'm going to leave that one alone. That's the only place CO2 shows up, so I know that has to stay that way. Then going down, we'll just look at the other product. The next product, SO2 is on the product side, and it is in this reaction here, but it needs to be multiplied by 2. So I'm going to go through, multiply through the equation by 2, which means that I'm going to also multiply the delta H by 2. And I'm just going to mark through that because I'm done with that one there. And so now the SO2 in here, it's on the correct side and it's got the correct coefficient. So I'm just going to circle it so I know I'm done with that one. Now the SO2 or the CS2, I have it's on the wrong side, but it does have the right coefficient. So I need to flip this last reaction. So CS2 yields carbon and 2 sulfurs, and flipping the reaction is going to basically just change the sign without changing the value. And so now this is where I need it to be. And then my 3 oxygens, if I look, I have 1 oxygen from that first reaction plus the 2, both are on the reactant side, so that's going to give me my 3 O2s. So my delta H then is going to be equal to minus 393.5 plus a minus 296.8 times 2 plus a minus 87.9, which gives me a total, if I remember right, it was like minus 1075 kilojoules.